Okay, so let's talk about solving trig equations. This time, solutions when the angles are on the axes. So, 90, 180, 270, 0, 360. Then we'll also talk about solutions when I go not from 0 to 360, but negative 360 to 360. All right. Okay, let's start with this little review. So remember we did our nice little unit circle. And when we say that, right, it's just right triangle trig with hypotenuse of 1. That's what I mean by a unit circle. All right, so if we did this, then, right, first of all, we know that sine of theta is y over 1. So sine of theta is y. Cosine of theta is x divided by 1. So cosine, or x is cosine theta. And then tan is y divided by x. All right. Okay, we also use this for our sine charts. So since sine is y, then sine's got to be positive in the first and second and negative in the third and fourth. All right. Again, since cosine is x, then cosine is going to be positive in first and fourth and negative in second and third. Okay, and then since tan is y divided by x, right, then tan has to be positive in the first and second, or first and third, right, because negative, negative will be a positive. And then the first and fourth, or I'm sorry, good. The second and fourth have opposite signs, right? So x is negative here, y is positive, so that'll be a negative. Then x is positive, y is negative, so that'll be a negative. All right. So again, we use this unit circle idea, which again is just a right triangle trig with a hypotenuse of 1 to generate, first of all, these ratios or these identities: sine theta equals y, cosine theta equals x, and tan theta equals y over x, and these sign charts. Okay. All right. So let's talk about this. The sign charts are just good for the quadrants. They don't tell me what happens on the actual axes. So make sure you understand that. The sign charts are good for the quadrants, not the axes. All right. So now, what if we were to look at things on the axis? So, for instance, cosine of 0, right? That's a positive x-axis. Or cosine of 90, that's the positive y-axis. Or let's say tan of 180, that's the negative x-axis. Or sine of 270, again, that's the negative y-axis. Well, if I were to graph these, the positive x-axis is 0 would be right there. The 90 would be right there. Then 180 is the negative x-axis. 270 is the negative y-axis. And so you notice the problem here. Again, I need right triangle trig because it's sine, cosine, and tan, and I cannot form any right triangles. Right? So again, we're at that same dilemma where we need to use right triangle trig without actually forming right triangles. Well, how are we going to do this? Well, we know if we form this general right triangle with a hypotenuse of 1, then y is really sine theta and x is cosine theta. So that tells me that the vertical distance of this side is sine theta, which is y, and the horizontal distance is cosine theta, which is just the x. Well, it's a hypotenuse of 1, right? So if I drew a circle, so I have, this vertex right here at 0, 0, then this is where we get that nice unit circle. And since it's a radius of 1, on the x-axis, this has to be 1 comma 0. On the y-axis, this has to be, 0 for x, 1 for y. And then the negative x-axis is going to be negative 1 right here, because again, the hypotenuse, the length, right, of this radius is 1. And down here, the y is negative 1. Well, now this is wonderful, because I know sine in terms of y, cosine in terms of x, and tan in terms of y over x. And I have now ordered pairs at all these points. Okay, so if I want to figure out cosine of 0, since cosine is x, it's this x coordinate. So cosine of 0 is 1. Right? Cosine of 90, well, again, cosine is the x coordinate, and the x coordinate is 0. So cosine of 90 is 0. And then tan, so tan is y divided by x, so 0 divided by negative 1. So tan of 180 is 0. And sine, since sine is y, the y value right there is negative 1. So sine of 270 is negative 1. Okay, so we're going to figure out the axes. So do the trig ratios of the axes. We actually use the ordered pairs and then these equalities. Okay, all right, so let's go backwards. Let's say I know that sine theta equals 1, and I want to solve this for theta. Well, I have to recognize for cosine and sine that when they're equal to 1, either positive or negative, that means it's on one of the axes. All right, so if you go back, remember sine is y, cosine's x. So 0, 1, and negative 1s are all these points for x and y. All right, tan's a little different since tan's y divided by x. If you get a 1, that means it's 45 degrees. Right, but tan, if you get a 0, it means it's on one of the axes, right? Or if you get an infinity, like divided by 0. Okay, so let's try this. So sine of theta equals 1. Well, let's start here. I know that sine of theta equals y from my basic unit circle, which again is just a basic right triangle with a hypotenuse of 1. Well, here you go. So when I work around here, since sine is y, at 0 degrees, y is 0. At 90 degrees, y is 1. At 180 degrees, y is 0. And at 270, y is negative 1. So the only place y is 1 is right here at 90. So what's the value of theta when sine of theta equals 1? Theta has to be 90 degrees. Okay. All right. Okay, so you want to stop this? You want to complete class with problem number 1. So figure out the solve trig equations when the angle is on the axis or on an axis. Okay, so let's talk about positive and negative angles. So it should be a nice little review from your trig or geometry. So if you want to do a positive angle, then you go clockwise. So starting at 0, 0, that would be or I'm sorry, I said clockwise, but I meant counterclockwise, CCW. So kind of go up and to the left. Going to the 0 degrees, if you want to do a negative angle, then you go clockwise, which is down. All right. So from 0, if you go up, that's counterclockwise. If you go down, that's clockwise. Positive up, negative down. Okay. All right. So if I'm going to graph, let's say 60 degrees in the positive and negative 160 in the, as a negative, then my 60 would start at 0, 0 and go up. So that would be a 60-degree angle. And my 160 in the negative would go from 0 and go down, and that would be an angle of 160. Okay, you'll notice the negative tells me what direction to go in, clockwise. I don't write negative 160. This is 160 degrees. It's just from the x-axis from 0, rotated clockwise. That's what that means. Okay? Okay, how we're going to use this is this idea. Well, I can get to this line two ways. I can go a positive 60, or I can go down and loop back around like this. Well, if I do that, they will both map out the exact same line. But this red angle now is 60 minus 360, which is negative 300. So I can always map out this kind of, if you drew an altitude to this right triangle, I can map out this hypotenuse, this line, this ray in two ways, go positive angle or negative angle. All right. Okay, and that's what we're going to do now. So I want to solve sine theta equals negative 1/2, right, 0.5. But now I want it for all negative angles greater than 360, all the way to all positive angles at 360. So now I want positive and negative angles. Well, first thing, right, we started off with solving things on the axes, but this is negative 1/2, so I know it's not going to be on an axis. So either way, though, it doesn't make a difference. It's just nice to know. So let's start with this, right? Every trig ratio except on or trig equation, except for solutions on the axes, will have two answers between 0 and 360. Well, that means that if I have two answers between 0 and 360, I can get to those two answers in the negative direction, right? If you think back to the blue line and the red line. So I'm going to have a total of 4, okay? All right, so my job is, let's do what we did before. Let's just inverse sine both sides, and here you'll get negative 30 degrees. Well, that's my first solution, and that's one of the negative numbers. All right. Well, if I were to graph this right triangle, it means that I start on the 0, right, degrees, and I go clockwise to get this right triangle. That's what that means. So negative 1/2 would be the ratio of these two sides, right? Or I'm sorry, the opposite side of the hypotenuse. Okay. Well, while I'm here, why don't I find the positive? So why don't I go to 0, start at 0, and go counterclockwise to get to this line, this hypotenuse? Well, that's easy enough. So the whole thing is 360, and I'm just going to get rid of this 30. So that'll be a 330. All right. So you'll notice what I actually did, which is added 360 to this first answer. And that's a wonderful key concept. So if your equation solves out to be a negative for your first angle, just add 360 and you'll get the positive version of it. All right. Okay, so now we need our second answer. Right. So here's where we'll use our sine chart. So the sine is y, and I want y to be negative, so it's negative 1/2. So we know sine is negative in the fourth and the third. So my second triangle will be right here. And so now I need to get to this hypotenuse two ways, one counterclockwise and one clockwise. So let's start with counterclockwise. So go from 0 all the way to this hypotenuse, and it's 180 and then plus 30 more, right? So that third angle is 180 plus 30 more, 210. And then lastly, I need to get to that same hypotenuse in the negative direction. So I'll go clockwise. And you can see all I need to do is actually subtract 360 from this. And that's how it's going to work, right? So if you have a positive and you want the equivalent negative angle, just subtract 360. Right? If you have a negative angle and you want the equivalent positive, add 360 because they have to form a whole circle, right? So there you go. In this case, though, I just kind of went through the picture. So it's going to be a negative 180 plus 30. So this will be negative 150 because if I do this, right, I go 150 and then 30 more would be 180. So I need this red would be 180 minus this 30, right? But in the negative direction. Okay, so a bunch of ways to look at it. Again, you don't have to do it this 180 plus 30 way. You can always just subtract 310. All right, so same thing. If you get a negative angle, add 360. I think I said 310, but the idea is if you have a negative angle here, add 360 to the positive. If you have a positive angle, subtract 360 and you'll get the negative. Okay, it's a wonderful key concept. Okay, let's just check them out real fast. So I'm suggesting that these two angles produce a ratio of negative 1.5. So sine of negative 30 is negative 1.5, or negative 0.5, right? Sine of 330 is negative 0.5. And now I'm suggesting these are the other two. So sine of negative 150 is negative 1.5. No, I'm sorry, I keep saying 1.5, negative 0.5. Okay, sine of 210 is negative 0.5. Okay, so you'll see those four angles will produce this ratio of negative 0.5. So those are all the negative and all the positive within this, one circle counterclockwise, one circle clockwise. All right, and that's it. So that's actually the end of the video. You're going to stop this and just complete class with problem number 2.